Alexey Melnikov. I work in a small company in Great Britain, ISO Limited. I'm involved in electronic mail and web mail, email. And the second part of my life is dedicated to that. I'm an IETF in application and art area director. I will do it in English. Lots of technical terminology. If I start translate, so 20 minutes will not be enough. So I will just switch into English. Lots of terminology.
I'll talk about a couple of technologies used by email. One group of technologies is related to protecting incoming mail from phishing and spam, like SPF, DKIM, DMARC, and more recent development, which is ARC. Very short slide on DKIM crypto update. And another section is talking about protecting email traffic between organizations, MTA, STS. I have a few slides about email, SPF, and DKIM, but I would like to know how many people know what SPF and DKIM is. Okay, so I'll try not to make it a tutorial, but I have a few slides explaining the background. So hopefully, because a lot of technologies in anti-spam and phishing, they sort of build on top of each other. So you need to have a little bit of background. So base email is described by two RFCs. RFC 5321 is SMTP, is how to send email messages from senders to recipients, and RFC 5322 is about email message format itself. So when sending messages, there is SMTP envelope, which describe information about transactions where email is going and where the bounce messages should be sent. And then there is the message itself, which consists of message header. For example, it includes as one of the headers from header fields, so who authored the email message. And the envelope from and from header field, they don't actually have to be the same. So whoever authored the message and whoever submitted the message to the mail system, they don't have to be the same. Sometimes there are legitimate use cases for this, like mailing list or secretaries sending messages on behalf of other people, but there are also a lot of abuse of this by spammers. So one of the biggest problem in email today is trying to protect from phishing and spam. So phishing is when messages pretend to be coming from respectable organizations, but they're actually coming from somebody else, and they are trying to trick you to either disclose some personal information or click on URL and according to research, about 90% of various attacks on networks starts from phishing. So this is quite a big problem that people would like to solve. As I said, phishing emails, in many cases, they look like real messages, like normal messages. It's very hard to spot the difference from, message from your bank versus a phishing message pretending to be from your bank, even if you're a technical person. Traditional anti-spam mechanism that, like, if you get a spam which tries to sell you something, it might use special keywords that are more easily identifiable by anti-spam systems, but this doesn't quite work for phishing because messages pretend to be normal messages. So, but there is a set of technologies like SPF, DKIM, and DMARC that are trying to combat this. So, very quickly, a couple of slides how SPF works. Basically, it describes which SMTP servers can send mail on behalf of a domain. So, on the left side, you have at domain like, all messages from example.com, and you have potentially 3 MTAs listed, MTA1, MTA2, MTA3. And you publish DNS TXT records that can specify basically which MTAs are allowed to send mail. There is a special language. It starts with the version field to distinguish it from other types of DNS records. You can specify IPv4 blocks, IPv6 blocks. You can say that all the servers designated as MX exchangers can also send the mail out, and there is a mechanism for including other records. So there is a bit of a recursion here. So the way it works, so if we have, let's say we have MTA1, MTA2, and MTA3 as designated SPF senders for a domain, then if a message from another spammer is trying to submit message directly to receiver, a receiver will check the DNS record, and it will detect that it's not coming from one of the designated MTAs, and it will reject it. But the other side of it is if your users are participating in mailing lists, so although messages will be sent from designated MTA to the mailing list, when it gets forwarded from the mailing list to the receiving MTA, it will look to receiving MTA as if it's coming from spammer. So basically, SPF doesn't work for mailing list and forwarders. Another technology used is DKIM. It provides a mechanism for organization to claim responsibility for a message coming from it. It does it through a cryptographic signature. It's added to the message when it leaves the outgoing mail transfer agent, and keys that are used for signing different messages are also published in DNS, so the receivers can look at the added header and verify whether it was signed by the right key, and can verify that it wasn't modified. So this is just an example message with various headers fields in it, like it's from, to, like subject, etc. With yellow stars, I marked headers that can be potentially signed. DKIM allows signing of arbitrary headers, but this is the typical headers that are being signed. And it can also, green star is also showing that the message body itself can also be signed. So it's also can be prevented from being modified. So this is how the header field, DKIM signature header field looks like. It has it's a set of attribute value pairs. For example, A equal is designate cryptographic algorithm used. D specifies the domain that generated the signature. S specifies the selectors, so the domain can have multiple signing keys, for example, for different purposes, so for subdomains. H specifies which headers were signed. B is the signature itself, etc. And in DNS, the record is going, for this example, the DNS is going to be selector, which is IETF1._domain_key.ietf.org, and it will look like, again, key equal the RSA signing mechanism, and P is the public key. So similar to SPF, there is a problem here, is that if the message has DKIM signature, and if it goes through the mailing list, for example, that decides to add a prefix to subject line or append a short disclaimer to the end of the message saying, well, this got received by mailing list, this actually breaks the signature. So again, it doesn't actually work with indirect mail flows. So here comes DMARC. DMARC is a technology that is building on top of SPF and DKIM and trying to make certain things better and certain things worse slightly. Similar to SPF and DKIM, there is a DNS TXT record that published DMARC policy. Message authentication is done based on SPF and DKIM, and there is a separate piece which is quite interesting, can be quite interesting for ISPs and mail providers, is reporting piece. So the sending domain can get reports about how its domain name is used or abused by other senders. So this is how DMARC policy looks like in DNS. Again, TXT record, so it starts with the version number, so it can be distinguished from other things. Then it's a set of attribute valued pairs. P specifies the policy, what to do with the message if it doesn't, if it fails DMARC checks, and I will talk about this a little bit later. And fields like RUA are specifying, asking recipients to send aggregated reports about use of DMARC and where to send them. You can specify multiple recipients. And RUF also allows to sender to specify to send failure reports. So policy. Typically, there are three types of policies. In this field, P equal reject is the most strict one. It specifies that if the message fails DMARC validation, then it should be rejected, so the message should never get delivered to recipients. P equal quarantine is saying that if message fails DMARC, then quarantine the message just in case, you know, it's actually a legitimate message and it can be released by administrator or maybe even user, but by default is not going to be delivered to inbox. And P equal none is basically saying don't do anything special with the message, just deliver it as usual, but this helps to for the sending domain to receive DMARC reports. So, and I'll talk about this a little bit later. So how does DMARC builds on SPF and DKIM? So with E, it's a message envelope on the left, and M is the message itself. So envelope is used for SPF checks. Message headers are used for DKIM checks. Then it's being fed into DMARC engine, and it verifies that both SPF and DKIM work. And for this, it used the concept called identifier alignment. Is basically a way of saying what kind of addresses are allowed in envelope and messages, and whether they need to be identical or whether one can be subdomain of another. So it depends. In the simplest case, the policy just means that they should be the same. If DMARC engine sees that both SPF and DKIM validation succeeds and identifiers are aligned, then basically the DMARC policy specified by the sender is applied to the message. So now, if the DMARC validation fails, the DMARC policy specified by the sender is applied. If validation succeeds, then the message gets delivered as usual. Just another slide about what different attributes are in DMARC policy records. So already talked about the version number, policy type. There is a field for PCT for percentage. So for example, it's possible to say that to only apply DMARC policy to a certain percentage of emails. So it allows administrators to roll out DMARC slowly, starting from small percentage and just go up and see, observe reports and see whether there are any misconfigurations, whether there is any downside to using DMARC. Then there are a couple of fields for specifying where to send aggregated reports and failure reports, and more specific controls of how messages are validated. Reporting is quite an interesting piece of the puzzle. As I said, the RUA attribute can be used for aggregated reports. They are XML or zipped XML. There are some tools and companies doing parsing and displaying graphs and helping out with analyzing things. These reports are sort of trying to kill two birds with one stone. They both help to see whether there are any misconfigurations by the sending domain itself. So, for example, if administrator forgot to include some MTA as a part of SPF allowed list of MTAs who are allowed to send messages out, then this will be spotted through reports. But it also helps to see who is trying to spoof and misuse your domain. And there are also failure reports. They are generated for each message that failed validation, whether it was a spoofed message or just something sent through misconfiguration, but this can generate quite a lot of traffic, so be aware of this. So now, a little bit of statistics to show how DMARC deployments are changing over time. So in the last year, internationally, DMARC deployments increased 3 times. You can see by countries, some countries in Europe are leading the way, but you can also see that Russian Federation is actually on the list, so nice to see. General trends. So DMARC is mostly deployed in consumer space, so enterprises are lagging, mostly being deployed by big companies, email providers, banks, government organizations that are being spoofed a lot. Basically companies that try to do brand protection. So if you want to deploy DMARC, then you probably should start with policy p equal none. This will enable generation of reports, so you can observe how your domain is being used. Then you can move to p quarantine, and then start with small percentage, and then increase it. And then, if you are very brave, you can switch to p reject. But I'm trying to talk quickly about some downside of this. So, as I said, both SPF and DKIM, they don't work very well with indirect mail flows like mailing list of orders or filtering services. Because they change the message, or they change where the message is coming from. So typical side effect, if somebody with strict p equal reject policy sends a message to a mailing list, first recipients who enforce DMARC are probably not going to see it, and second, there would be bounces from this message that go to mailing list manager, and recipients who enforce the policy get unsubscribed. So this is quite a bit of headache. Long-time fix is ARC. I will very quickly talk about it. There are also some various ways of doing workarounds that mangle messages in different ways. I'm going to skip this because I'm a bit short on time, but you can have a look at the slides. So ARC is a document that is near completion in IETF. It basically allows intermediary to add its own signature, saying, you know, this is the status of the message as I received it. That's what SPF and DKIM said when I received it. And then this allows recipients to check what happened to the message, where the signature got broken, and maybe if they trust intermediary, they will deliver it. So ARC builds on DKIM. There are 3 header fields. One records SPF DKIM results. The other are 2 types of signatures. DKIM code can be relatively easily reused for this. This is a big example I was trying to show. I'm not going to show it now. I'm just going to whiz through. It just basically shows message going through 3 intermediaries, each adding its own set of ARC header fields. So how can ARC be used? So presence of a valid ARC chain. So if recipients would reject message due to DMARC policy, it might defer to ARC and see if there is a valid ARC chain, and then it might deliver this message instead of bouncing it. ARC also helps to debug issues with intermediaries if there are some unintended changes to messages. So unfortunately, there is a big elephant in the room. ARC depends on reputation. So if the message goes through a mailing list you don't know anything about, it's hard to trust whether the message, whether it's a good mailing list. It might be operated by spammers or phishers, who knows. So really, it depends on the reputation system. And there are some open issues related to possible abuse of ARC, but this requires some implementation deployment. The other interesting side effect of deploying DMARC and ARC is they are increasingly more widely deployed, and they are probably going to cause phishers to use hacked accounts more so that they work within the existing DMARC ecosystem. I'm going to script this. The other thing I wanted to talk about, but I might have a minute left, is about strict transport security. Is basically a mechanism to protect SMTP links between organizations. The way it's done is there is a DNS record saying that please always use *TLS with me when talking to me. And then there is a short policy document published by receiving domain that specify exactly policy, what to expect in certificates, and how to check that. This is how DNS record looks, and this is how the policy document looks like. So, to summarize, DMARC builds upon SPF and DKIM, helps to protect from misuse of your domain by recipients. Doesn't quite work with indirect mail flows, but ARC helps with that. And if you want to protect domain-to-domain email traffic, please use STS, which is also just about done in IETF.
Alexey, спасибо за доклад.
Alexey, we thank you for your presentation. Time for questions. Yes, please. Oleg from Mobile Systems said, yeah, I discovered some reports between the men. Probably a letter came, reported, and no reports I saw. What's the way to fight it? So there is no useful information between the domains anymore. Reports should go from empty mail from. So there should be no cycles. So it's a bug with the software, most probably. So it means that a bilateral bug. No, report comes only once. There is no response. Once a day from the domain, I get a report, and I send a report back. So report to report, report to report to report. There's a bug with configuration or software that you have. It shouldn't be that way. It shouldn't work that way. More? Yes? Hi, Melnikov Anatoly from Telefond Ukraine. Could you please tell us if the source of the mail is IPv4, but the receiver IPv6? So do the policies work at this level? No. It's a problem of lower transportation, so the policies won't help here. So if the questions are exhausted, I might ask one about from a person who is not a connoisseur, but who has a problem. We have a Barracuda mail service. It's a large, popular, and for some reason they have blacklisted us. We cannot get out of there. So they don't respond to no mail, to nothing, to requests. And we ask them to remove, to de-blacklist us. How RTF looks at it? When some private companies have gateways and use it as a service, and the service turned out low quality, I'm not sure this matter may be addressed at IETF. Well, no, it's not. It cannot be addressed in this way. Many companies do. Reputation problem, and Barracuda is a company who estimates reputation. And the secret how they do it, it's our confidential information they don't share. There are no standards in this area. So the question, yes, interesting, but so far out of the, it's not within our scope. It means that it's out of everybody's scope. So if you turn out to be there, you suffer. And our users suffer, right? In any case, we thank you so much. Yeah.